Welcome back, everyone, to another Explainer. Today, we are diving into something that has literally completely changed the landscape of open source AI. We're going to be focusing on the incredible efficiency behind Ollama's vast ecosystem of integrations. Because, if you've ever tried to run a large language model on your own hardware, you know it usually involves a lot of crossed fingers, cryptic error messages, and maybe, just maybe, a small desk fire. But Ollama really changed the game here. And today, we're going to break down exactly how they built an architecture so wildly efficient that it spawned an entire universe of developer tools.
Just think about that for a second. What if running a powerful local AI was as easy as running a single line of code? Historically, getting local models off the ground meant fighting with complex Python environments, wrestling with CUDA drivers, manually downloading massive gigabyte-heavy model weights, and then basically just crossing your fingers that your machine wouldn't crash, right? There was just an incredible amount of friction. Well, let's explore how Ollama became the ultimate frictionless silver bullet for this problem, literally turning a multi-day engineering headache into a 30-second download.
Okay, let's dive into this. Here is our roadmap for today. We're starting with the local AI engine, moving to frictionless setup and APIs, checking out efficient developer tooling, taking a look at the app integration ecosystem, and finally, wrapping up with the future of local AI. All right, Section 1, the local AI engine, the hub of efficiency. So before we can really appreciate the thousands of apps built on top of Ollama, we kind of have to look under the hood to understand the underlying architecture that makes this tool so remarkably lightweight and adaptable across different machines. When I cracked open their GitHub repository, I was fascinated by a very deliberate, highly efficient choice in programming languages. Look at this. 69% of the repository is built on Go, and 24% is built on C. This means we aren't looking at some bloated resource-heavy web app. Actually, Go gives us incredible concurrency and networking capabilities, perfect for handling API requests and managing processes. Meanwhile, C gives us that raw, close-to-the-metal performance you absolutely need for actual machine learning inference. Together, this Go and C split forms a performance-driven core that really acts as the perfect, streamlined engine for the whole ecosystem we're about to explore.
Moving right along to Section 2, frictionless setup and APIs, standardizing the spoke.
Now, once we have this highly efficient engine, how do we actually connect to it without pulling our hair out? Well, it's brilliantly brief. Step 1, download for your OS, Mac OS, Windows, Linux, or even Docker, whatever you're using. Step 2, open up your terminal and just type Ollama run Gemma 4. Step 3, you are instantly chatting. I mean, you can go from absolutely zero to having a conversation with a highly capable model like Gemma 4 in just 3 incredibly fast steps. The software handles all the heavy lifting, pulling the weights, allocating memory, spinning up the inference engine. It's all happening entirely in the background. It abstracts away all that complexity.
And this frictionless experience extends perfectly to developers too. In the past, every local model or framework demanded its own complex custom implementation. It was a mess. Contrast that with Ollama's standard REST API. It uses really simple JSON endpoints that are incredibly easy to hit. But wait, here is the absolute stroke of genius. Ollama recently updated their software to perfectly match OpenAI's streaming wire format for chat completions. So what does this all mean? It means if a developer has already built an app designed to talk to OpenAI, they can literally just swap the API-based URL to point to their local Ollama instance, and boom, it just works. It's the ultimate frictionless integration, providing maximum developer ease.
All right, Section 3, efficient developer tooling, building the middle layer. Now, what's really interesting about this is seeing how that standardized API actually translates out in the wild. What absolutely amazed me is that you never have to reinvent the wheel here. Whether you code in Python using LangChain, Semantic Kernel, or Light LLM, or maybe you're in JavaScript using Llama Index TS. Even if you're building massive enterprise apps in Java with Spring AI, or seeking that high-end performance in Rust with Ollama RS, the community has already built that middle layer for you. Because the core engine is so rock solid and the API is so standard, the community has confidently invested their time into building dedicated libraries for virtually every major programming language on Earth.
Which brings us to Section 4, the app integration ecosystem, or as I like to call it, the outer wheel.
Okay, we're zooming all the way out now. Because of this efficient, standardized foundation, the open source community has just completely exploded. The Ollama repository has amassed over 177,900 GitHub stars, and it's sitting alongside over 17,300 forks. Guys, this isn't just a popular tool anymore. This is a paradigm shift. To put that into perspective, this number is the ultimate proof that a developer-friendly architecture paired with a frictionless setup leads to massive, unprecedented adoption. Developers love tools that just get out of their way, and honestly, that's exactly what Ollama does.
And because of that massive adoption, we are seeing some blistering development speeds. You've got these beautiful self-hosted browser interfaces like OpenWebUI and LibreChat springing up, but it doesn't even stop at the browser. Apps like Enchanted and Made are bringing native cross-platform experiences right to your desktop and even your mobile phones. And the crazy part? All of these different apps across all these different platforms are powered by that exact same lightweight local engine we talked about at the very beginning.
Let's look at how this builds directly into a developer's daily workflow, giving this massive productivity boost while staying entirely secure and private. Since Ollama runs locally, it plugs right back into your favorite IDEs. You have Qwen, which is a VS Code extension capable of whole repository coding. There's Continue, an open-source assistant for basically any environment you can think of. You even have Void, a complete open-source AI code editor, and GPTel, which brings an LLM client directly into Emacs. You don't have to change where you work, the local AI just comes to you, operating right alongside your code.
And this ecosystem scales right up to some complex enterprise needs, which is absolutely crucial if you work with data. Think about it. You can securely connect local models to private databases without ever sending your sensitive corporate secrets off to some third-party cloud provider. You can use tools like RAGflow or MaxTB for document understanding, meaning the AI is actually reading and retrieving context directly from your specific local files. You can use PGAI to turn your PostgreSQL setup into a vector database and then orchestrate the whole shebang using Crew AI to build out multi-agent systems. The sheer efficiency of Ollama's API means these really complex systems communicate seamlessly and with incredible speed.
Finally, Section 5, the future of local AI. Where do we go from here?
So we've seen the hub, the spokes, and the massive outer wheel of this whole ecosystem. But what are the broader implications of a tool that's this wildly efficient? Well, the future is deployment everywhere. What started as a neat way to easily run models on a single laptop has scaled effortlessly into full-blown production infrastructure. Today, Ollama's efficiency isn't limited to just a MacBook. You can deploy it using official Docker images for containerized enterprise solutions. It is baked right into standard package managers like Homebrew, Pacman, and Nix. And it's fully supported across major cloud platforms, from Google Cloud to Fly.io to Koeb. This basically means the exact same frictionless workflow you use to test a model at your desk is exactly what your ops team can use to deploy it to millions of users in the cloud.
So here's the absolute most crucial point. All of his architecture, the Go and C foundation, the frictionless CLI, that OpenAI-compatible API, the massive web of developer integrations, it all exists for one single powerful reason: to give you immediate, frictionless access to the most powerful open models in the world. Whether you want to test out Kimi, GLM, DeepSeek, Qwen, or Gemma, Ollama ensures that the software getting you there is never going to be the bottleneck.
We've seen how this incredible tool completely ripped the friction out of local AI, sparking an absolute explosion of creativity across the open source community. So I want to leave you with this final provocative thought for today. With an integration ecosystem this efficient and the friction completely removed from the equation, what are you going to build at the center of your own local AI hub? The tools are right there waiting for you. Thanks for joining me on this explainer, and I'll catch you on the next one.